Hello, today we'll be talking about RSA Cipher. RSA is a public key crypto system that is widely used for secure data transmission. It is also one of the oldest. Right here, you'll see the inventors on screen. The RSA Cipher is actually an acronym of the names of the individuals. R as in Reverse, S as in Shamir, A as in Edelman. Now, let's talk about generating public and a private key pair. First, we'll have to choose two large prime numbers. Secondly, we need to commute two mods, one mod being m and another mod being n. M will be made out of the multiplication of p and q, while n will be p minus 1 multiplied by q minus 1. Next, we have to choose d. Now, the conditions for d will be d has to be smaller than m and have no common factors with n besides the number 1. Next, we'll have to solve for e such that e multiplied by d mod n will equal to 1. In other words, d minus 1 is exactly divisible by n. And there we have our public key, which will be represented as e comma m. This will be known to the public, and our private key, which is represented d comma m, and this will be a secret. Now, moving on to encryption and decryption. To encrypt a message, we will use the formula shown where P will be the plain text and C will be the ciphertext. In order to get C, we will need to use the formula P to the power of E mod M to get the remainder, and that will be our encrypted message. To decrypt a message, we'll use the formula shown there, P as the plain text number and C as the ciphertext number. In order to get P, we need to use the formula C to the power of D mod M to get the remainder, and that will be the decrypted message. Now, let's have an example. For this sake of an example, we'll be using smaller prime numbers, numbers 2 and 7. That will mean our M will be 2 multiplied by 7, which gives us 14. And N being 1 multiplied by 6, giving us 6. Now, as for D, we will have to be smaller than M, and which is 14, and have no common factors with 6 besides 1. Let's choose 11. Now, solving the equation with 11 substituted in will give us 5, and that will be E. So our public key will be EM, which in this case is 5, 14, and our private key DM, which would be 11, 14. Now, how do we encrypt this message? The public key from the previous slide, as known, will be 5, 14, and we can encrypt our secret message, which is the letter B. But now instead of encrypting the letter, we should assign a number to the letter. So let's use the number 2, which means the rest of the alphabets will be according. A being 1, B 2, C 3, and etc. Encrypting the values, we will substitute the numbers into the formula from the previous slide, which gives us 2 to the power of 5 mod 14. The result is 4. 4 is the encrypted message, which translates to D. Now let's learn how to decrypt a message. We can decrypt the encrypted message, which is D. Now that D translates to 4, we can use the number 4, substituting the numbers into the formula, which gives us 4 to the power of 11 mod 14. The result is 2, which translates to B. And there you have it. We have successfully encrypted a plain text message using the public key and decrypted the ciphertext using the private key. Now, let's move on to some history behind the creation of RSA. The three geniuses, Vest, with Shamir and Edelman, attempted to develop a crypto system to enable secure encoding and decoding between communicating parties. As Rivest and Shamir worked to develop an unbreakable key system, Edelman, being the mathematician, tried to break each one. Edelman had to break over 42 times before the trio achieved success. Now, unlike uh, previous methods requiring securely exchanged keys to encrypt and decrypt messages, RSA provided a method for encryption and decryption without both parties needing a shared key. RSA would also be able to mark messages with a digital signature and allow originators to create messages intelligible only to intended recipients. That will mean that third parties intercepting such transmissions would find them indecipherable. This is what makes RSA the most commonly wide used public key cryptography method for securing communication on the internet. My personal thoughts on this is that RSA has contributed to so much of the internet that we have in the modern world. There are things that we don't even know previously are already being used by RSA, be it the growth of e-commerce or safeguarding uh, sensible data such as credit card numbers. I personally feel that the three people responsible should get more credit for what they did, and it's going to be exciting to see what future technology can be created, or maybe even better encryptions can be created from the inspiration of RSA.